Well, hey y'all, welcome to week 6. For this part of the course, we are, moving into the program design phase, more about talking about, developing a program and some additional things to think about, particularly from the program design side and the measurement tools that you're going to use for a program that you create that you would know that has some effectiveness. How do you know that the program is effective in this? So there's some thought that needs to be given to the design and the tools that you're going to use outside of the statistics, the quantitative and qualitative piece of the tool. So chapters 13 and 14 give some good information about this. And as you read through those chapters, I think some of this can become a bit clearer and what that means. So really there's some overarching basic concepts that Latin and Berg dive into in these two chapters to give a bit of clarity there. And I'm hoping maybe to add some examples to that of how I've used this in some of the projects that I've worked on in the past. And I think that it can be helpful as you think through a project that you would design also. So really chapter 13, the title of it is on measurement and data collection concepts, and mostly talks about validity and reliability. But it really starts off by saying there's two important qualities to be considered relative to the research tool, which are accuracy and its consistency of measurement. And so remember this, and I'm gonna, I think keep emphasizing this within the course, that you don't have to be a hardcore researcher to think like a researcher, particularly when you're talking about the programs that you can design for the folks that you're working with, and that there's an important piece to that, and that is some type of measurements to know that your program actually works. So that's the fundamental question. Does the program that I've designed for my patients who have, for instance, type 2 diabetes, do the measurements actually show that the program is effective? How do you know it's effective? And it's important to know that so that you can go back and make some little adjustments within the program to perhaps fill those gaps, to say, well, okay, so we're short in this area is not going so well, but we're really strong in this area, so why don't we keep the things over here? Let's tweak some things over here. So how do you know that one area of the program is strong and one is weaker? And so that's by taking some measurements. And so, of course, that's, as I've talked about many times, that's what we've done in the cardiovascular and diabetes risk reduction program, which for this week is a couple of the articles are assigned readings there for this week. So kind of gives you some idea about the measurements that we have taken in that particular program to know how well it's working. Okay, so I'm really talking about here, the first thing that they jump into here is validity. So validity is as they define it here, the extent to which a test measures what it is supposed to measure. Okay, so how do you know that if so for instance, we are developing a program within the medical school to try to alleviate physician burnout and improve patient care by focusing on compassionate care. And I think I may have mentioned this previous, there's a connection there from research to show that the more compassion that a physician or healthcare provider gives to a patient, that the less burnout they feel themselves. So their burnout and stress improve the more compassion that they give to their patients. Okay, so that research has been done But what so we're building on that research for the program we're creating. So what we would like to do is to use some type of tool to measure compassion in our physicians. We're specifically focusing on physicians at first. So what do we do there? How do we do that? Well, luckily there are tests that have been developed that can measure compassion. And so looking specifically at that, and so how do you measure compassion as well? That at least the tendencies for compassion, and I'm going to talk about the details of these tests in a little bit, or these tools, but what we're looking for is a tool that has some validity. Okay, so how do I know that XYZ tool that I'm using is actually measuring compassion? And this is the validity. This is a really important question for me and for this project, is that if I'm going to implement a tool that I'm going to use thousands of times to measure compassion at baseline, and then at some point down the road, or at various snapshots over time, I have to feel confident that the tool that I'm using is actually going to give me a valid result, that it's measuring compassion. Okay, so I could put together something that says, how compassionate do you feel? Or some questions that I might think are important, but they may not be measuring adequately or accurately measuring the compassion that I'm looking for. Okay, so I need a valid tool for that. The piece I think that is important here, and what I'm particularly looking for, and this is talked about in the book, is there's different types of validity for a tool. So you can get face validity, which isn't it's the lowest standard of validity, content validity. What I'm looking for in a tool is statistical validity in a tool. So is there a tool out there that can measure the compassion level of a physician, and that has been done so that has statistical validity to it? So this is the research that some people do, is that they develop tools like this and then test them in a way that they can show that it has statistical validity to it. And so that's what I'm looking for. And fortunately, there are those out there. Okay, so hopefully that gives a little bit of context around that. I did want to make one more comment, that there is another way, looking at statistical validity that we used in our cardiovascular and diabetes risk reduction program in looking at concurrent validity. And so this is another way to combine, so these things of, looking at a pre versus a post test here. So in our risk reduction program, and this may be similar to the program that you're designing, we had a tool, we used it at baseline to measure something. And then we used it again at a time point B in the future to measure the same thing, and then comparing the two measurements to see if there was improvement, and then doing some statistical tests there. So that's looking at, can we use this test multiple times in a program, and we've used that's a thought process we went through to say what tools work well. And I guess giving an example of that, we used a tool that the Center for Disease Control and Prevention used to measure how well people feel within the last 30 days. And that's a statistically valid tool that we could repeatedly use over time also, and felt like we were using something that measured what we were hoping to measure. And it was really, it's the CDC's quality of life tool, and we've used it many times because we feel confident that it is a valid tool, and it has been used repeatedly and over time by others to show the statistical validity. And so we felt confident to use it in our program. It's something I think for you to keep in mind when you're looking at tools, say you're trying to measure the improvement of sleep over time, or maybe the improvement of, it could be quality of life, could be well-being, could be compassion, these things that are maybe challenging to say, well, this person seems happier, but is there a tool to measure happiness that is statistically valid, that I can feel confident in using to measure a baseline happiness, and then implement a program that, and maybe one of the outcomes of your program is improved happiness? And the answer is yes, there's happiness tools out there that are statistically valid. So thinking about that is really important for your program design. And then the other main topic here is the reliability of it. So does the tool actually consistently and repeatedly measure what you're hoping to measure here? So reliability measures consistency and repeatability of test scores, or data collection. And so that's the other main part about it. I mean, you need to know that what you're measuring is actually what you're measuring, and that when you use it, you can use it over and over and be able to get a measurement, not only that's accurate, but as repeatably accurate. So both of these are important. So that's really the main part, I think, about chapter 13 in here, and it gives a lot of really good examples, and it goes into the topic, I think, very well, as most of their topics have been, in this book. So it may seem like, you're kind of getting into the weeds here, but this is a really, really important when you think about program design. The other thing I think that is worth mentioning out of chapter 13 is there's a table 13.2 on page 196 that talks about the commonly used statistics for validity and reliability. And so just pointing this out, and I mentioned for our risk reduction program that looking at concurrent validity is something that is important for us for the programs that we design and run, because we have pre-measurement versus points in the future, and then post measurements, and some of them anyway. That using something like a Pearson R or a Spearman R statistic is important for us to see this over time. So I felt like that was maybe important to point out, because it is something that may make sense for the program that you're putting together too. And so then on that same page, they give a reference talking about the validity coefficients and what the numbers might mean there. So an R value of 0.9 or higher is the most desired, but an R value of 0.8 is and higher is also acceptable. And they give a little caveat that if there's no better prediction method that exists, then they say that lower validity coefficients such as 0.5 to 0.6 are acceptable if you don't have a whole lot of options. Okay, so if you don't have these real nice tools to rely on that give you valid measurements. So anyway, I thought that was worth mentioning too when you're doing your statistics there, that's what you're looking for. Okay, so then going to chapter 14, it's really the title of this chapter is Experimental Validity and Control, and talking about internal and external validity. And just a couple things I think to point out here, that there are threats to your validity, of course, that are both internal and external. And when you're putting your program together and taking the actual measurements. So if you're, let me just give an example of like the quality of life questionnaire, the CDC one that I'd mentioned, that there is some threats to the validity of using that questionnaire, and that may be under your control. For instance, if you, and this is just a super easy example, but if you're giving a questionnaire to someone that is going to measure, let's say it's happiness, and the questionnaire has 30 questions to it, that maybe it's pretty extensive, or maybe it has 60 questions, that it's going to take some time for your participants to be able to answer. The setting that you administer that questionnaire to them matters. So do they have a quiet space? Do they feel like they have enough time? Are they in the right, in the right mind space to be able to settle into that questionnaire and answer them? Or is it going to be a situation where they feel rushed and they're just going to check boxes? It's not very valid, as you could imagine, if people are just going to go through the questionnaire as quickly as possible, not give a lot of thought to the answers that they're putting down. So you'll want to be able to control all of those threats to your validity as best you can, and that's what this chapter 14, is talking about here. So they give a list, table 14.1, it's on page 202, about internal and external validity threats here. And so there's just a couple that I really wanted to point out here. One is on page 204, and this is an internal validity thing talking about selection bias. And this is some of these things you just accept as maybe threats to your validity, and you just accept them as they are what they are. Okay, so an example, our risk reduction program, people self-select themselves into the program. This isn't something where the university says, you have type 2 diabetes, you need to go into this program. This is a voluntary program, and so we advertise it out there. People respond to these advertisements, or from word of mouth, they contact us to say, I'm interested in being in the program. That's clearly a selection bias because they're already interested in being in the program. So you know that they already have some type of movement towards a behavior change. It's not where they're on the behavior change scale and they have zero interest in trying to exercise more, for instance. They already have an interest in exercising more or eating right or whatever that is. So that's clearly a selection bias, and that is absolutely okay. I mean, we're not talking about an intervention that is going to be like a randomized controlled trial, as I'll give an example of in a minute, where we're taking just a member of Creighton University and then throwing them in a study to see if it actually works. This isn't that kind of program, and maybe yours isn't either. I'm going to guess that it's not. That your program was specifically designed for a certain group of people, and it was important for us in our program that these people actually wanted to be there. Because if they want to be there, then they're already a little bit down the road of a behavior change process. And so what we focus our time on is working with people who are already wanting to do something relative to improving their health, as opposed to trying to get all comers, everybody in the university trying to get everybody to eat fruits and vegetables. That's a different strategy, and that's not something we're really interested in. We just want to be we want to be cognizant of the people who are ready to make those behavior changes. Okay, so that's clearly a selection bias. It's something that we accept, and something that we acknowledge when we write these things up, and that the university understands. And those are okay. So some of those things you just say, well, that's just the way it is. It's okay. Okay, so the other thing too to be aware of is this Hawthorne effect. It's talked about on page 207. Something that we see all the time in research or a program like you're putting together. Okay, so when people are observed, they may have this behavior that is different than when they're not being observed. And happens in research all the time. And it's that generally people who are know that they're being studied or watched more closely have a little bit different behavior. So they might try a little harder. If they're keeping a lifestyle journal and they know that I'm going to look at that lifestyle journal and they know that I'm going to ask them about their what they've been doing over the last couple of weeks relative to their lifestyle behaviors, they're probably going to try a little bit harder because they don't want to come to the meeting and say, oh, I haven't done anything, or they don't want to have to write zeros down in their lifestyle journal. That's the Hawthorne effect. Is that an issue? I say no, it's not. I think it's actually it's something to acknowledge on our end that it is part of the deal. But certainly I don't think it's an issue relative to the program. It's really what you want to have happen. You want people to respond because they're being followed more closely. And I think that happens in health coaching all the time, that because they have to go back and tell their health coach how they're doing, sometimes they give a little more effort than if they weren't being observed, as they say in the book. So I just wanted to point that out, and that's just another one of those acceptable biases. And then external validity. The way you, in an ideal world, if you're doing a research project, you try to control for external validity by randomizing people into a certain group, intervention group, and then having a control group as well. A control group would be people who aren't in the study, but you're just going to measure them, but you don't do any intervention to them. It would be like a representative sample to see what they do over the next 6 months while you're working with another group to maybe improve their behavior in, say, getting more sleep. That you're doing intervention with this group, but you need to compare it to a group of people who you aren't working with to see if there's a difference there, or and if there's not, then maybe people are just getting more sleep or sleeping better for whatever reason. You can control for that. That isn't something how we design our that's not something how we design our programs. We don't use control groups because we're not really interested in people who aren't interested in our program. And that's absolutely okay, but it's something that you acknowledge as as a researcher, that you have some, perhaps some validity issues with it. There's a bias there because people are already interested. That is absolutely okay. Don't care, right? That is something that we aren't interested in people who don't want to be in our program. Those studies have been done in the past. We know that people who eat more fruits and vegetables improve their health, have better cardiovascular health, have better control over the diabetes. We know people who exercise, reduce their risk. We know people who lose body weight. Same. All of those things have been done by other researchers. You don't need to go back and prove those things by making this, tight research project. Build off of their research so that you can create a program that you can help the people that you're interested in. And that's really the idea there. So I wanted to just make those comments to make sure that you kind of understood it's okay, that you have some flaws in your research design. Most people do when you're developing programs for people to help improve their health. It doesn't have to be to the most strictest research design. But there are a couple of tables that can help with this if you're interested in that piece too, just to see how you're doing. So it's page 212 and 213, table 14.2 and 14.3, where it says controlling threats to internal validity and controlling threats to external validity. So I thought those tables were helpful too, and most of the answers are, randomize and control. That's how you control it. But for us, don't care. That's not the type of research I'm interested in doing. So anyway, I hope this information helps from your research design or from your program design standpoint, and that yes, you're doing research, but it doesn't have to be the most strictest research design in order to do some real good and real good for people in a nicely designed program that can help the people in the institution or a group that you're interested in. All right, hope that helps. Talk soon.